Okay, so in order for us to write proofs, we need to understand why we are writing proofs. So what is a proof? Have you ever argued with somebody and ended up providing facts or research that helped convince the other person that you were correct? If so, then you have been exposed to proofs. Proofs are just arguments or justifications that something is true. Now, we deal with proofs in all of our lives, maybe not formal geometric two-column proofs, but whenever we are trying to convince somebody that we are correct on something, we always need a justification or reason behind what we are saying. And so we are providing proof of the fact that what we're saying is true. So why are we learning proofs? In geometry, we learn something called a two-column proof, and it requires you to start with a theorem and then argue that theorem to be true by breaking down that theorem to its most simple form. Now, while you may not have to do geometric proofs in the future, geometric proofs or two-column proofs help you understand how to break something down into simple terms. And a lot of careers require you to break complex ideas down into simpler terms. For example, I have a couple of careers listed here. To be a teacher, we need to be able to take a concept and then break it into simple parts to be able to convey it to our students in a way that they can understand it. To be a lawyer, you need to be able to take all the evidence that is presented in the case and piece it together in a way that makes sense to the jury to create your argument. To be a computer programmer, you need to take a very complex idea that you have and break it down into simple steps to be able to program what you are trying to create. Now, these are just a list of a couple careers that require you to take something complex and break it down into simpler ideas. But there are many other careers that require you to do that as well. So can you think of any other careers that might require you to use proofs? When I say proofs, now again, I'm not talking about the geometric proofs, but I'm talking about taking a complex idea and breaking it down into simple terms. So I'm going to have you pause the video and think and reflect. Is the career that you are aspiring to go into, does that require you to break down a complex idea into simpler concepts? And then I put on here, now for each of these careers, we're not expected to write geometric proofs. However, practicing geometric proofs can help your brain understand how to take complex ideas and use facts to help you form simple arguments that lead to a final product. It's very important to train your brain how to do this, so that way when you get into the real world, you know how to break stuff down into simpler ideas. Now, proofs can be enjoyable if you allow them to be. So ways that you can make it more enjoyable for yourself is keep in mind that this is helping your brain understand how to derive arguments, which can help you in your normal life and also in your future career. And then if that's not enough to make you enjoy proofs, another reason you can think of a proof as a puzzle. If you like puzzles, you can relate each of these two-column proofs to a puzzle that you're trying to figure out. And we're actually going to be relating proofs to puzzles in the very next slide. So we are going to be doing a simple word proof. You guys are going to be practicing these word proofs. So your goal is you must get from your starting word to your ending word following a set of rules. So for example, my starting word is cat, my ending word is dog, but I am going to need to use a set of rules that kind of relate to what we're going to learn in geometry in writing two-column proofs. Now, in two-column proofs, you're going to be given something to start with, which will be called your given, and then you will be given something that you want to prove, which is what you're trying to prove. So you'll always be given a starting point and an ending point in a 2-column proof, just like we are today in our word proof. All right, so here are your set of rules. Rule 1, you must change only one letter in each step. Just like in 2-column geometric proofs, you must address one concept at a time. So you may be tempted to skip steps, and you may be tempted to include more than one step in more than one concept in one step. However, that is not allowed in proofs. You need to break it down into simple steps. Just like for this word proof, we need to change one letter at a time for each step. Rule 2, the word in each step must end up being a real word in the Merriam-Webster's dictionary. Just like in geometric proofs, each step must follow a certain set of mathematical ideas, principles, postulates, theorems. Your step must be true and must make sense. Those are your only 2 rules, but then I have some notes here to kind of help you. Now, note 1 is there's no specific number of steps. For some students, it may take you 4 steps to get from the starting word to the ending word, and for some, it may take you more than 4 steps, and that's okay. Just like in geometric proofs, there's not just one way to prove a concept. In fact, we talked about the Pythagorean theorem last year, and with the Pythagorean theorem, we did actually prove it one way. This year, we're going to see another proof of the Pythagorean theorem. In fact, there's over 367 different proofs of the Pythagorean theorem. So there's not just one way to prove that theorem. There's many different ways. And then note 2 is it doesn't matter how you approach a proof. You can work from the starting word to the ending word, or you can work from the middle out, or you could also work backwards. There's no one method that works for every student, so make sure you use what works for you. Just like with geometric proofs, some students like to work backwards from what you're trying to prove back to the given, and that's okay. It's up to you how you want to work it. So let's get started. We're going to start with the word cat, end with the word dog. Here's the solution. I'm starting with the word cat. I'm following my set of rules and only changing one letter at a time. So I'm changing my C to a B. And I get the word bat, which is a real word in the dictionary. And for my next step, I'm changing the letter T to the letter G to get the word bag, which is a real word in the dictionary. Next step, I'm changing just one more letter. I'm changing the letter A to the letter O to get this real word in the dictionary. And then finally, I'm going to change the letter B to the letter D to get my ending word. This is not the only solution though. So I'm going to have you pause the video and see if you can come up with another solution. All right, here's another solution. Start with the word cat. I'm going to change the letter A to an O for cat. I'm going to change the letter C to a D for dot. And then I'm going to change the letter T to a G for dog. You could have also found this solution, cat to cot, and then instead of to dot, maybe you went cog instead, which is also a real word in the dictionary. And then you went to dog. That would also be a solution. Now these are 4-step solutions. Maybe you found a longer solution. Maybe you found something like as follows. Here's another solution. Cat. Changing the letter C to an H, I get hat. Changing the letter A to an O, I get hot. Changing the letter T to a G, I get hog. And then changing the letter H to a D, I get dog. Again, these are not the only solutions, but these are more solutions that you could have wound up with that still works, still follows the set of rules, and still gets us from our starting word to our ending word. All right, so these are word proofs. and they follow the same set of rules that geometric proofs do. It's kind of like a puzzle. You're starting with something and you're ending with something, and you need to figure out how to get from the start to the end following the specific set of rules. And that's it. So you're going to practice this, and then we will get to our actual mathematical 2-column proofs.